Let's go. Let's look at example 5. I need you to look at example 5. I want you to tell me what rule you see we need to use here. Anyone want to, and type your answer in the chat box. What rule do we need to use for this guy? Yes, this is correct. Product rule. So the outside function is this whole thing, including the 5th power, and the inside function is this whole thing here. So for me, I don't love writing out the different pieces of the rule because I'm lazy, but I probably should. So for this example, I will. F of x is 3x plus 4 to the 5th power. And when we find the derivative, we need to use the chain rule. So, so that's going to be 5 times 3x to the plus 4 to the 4th power, right? Any questions? Do your instincts tell you something is wrong?
Supposed to times 3 again?
Times 3, yeah, times 3. It's just, yeah. You know what, maybe it was too soon. I thought, well, no, it's not too soon. You guys know that, right? You just were waiting for me to write another line. No questions, I hope. And then
So there's going to be like 2 different outside functions, or
so here's the key idea. This is a product rule, not a chain rule, not a composition. But when I look at the derivative of each piece of the product, I need to use the quotient rule. I mean, the chain rule, sorry. When I look at each piece uses the chain rule, but the actual main rule is product rule. Does that make sense? So I used the chain rule for this guy. I'm going to do the same thing for the second function. So when I look at the second function, g of x is equal to 2x plus 5 to the 7th. And then when I calculate g prime of x, that's going to be 7 times 2x plus 5 to the 6th power. Now I have to multiply by the derivative of the inside. The derivative of the inside is just 2, right? So again, I use the chain rule. For g prime. Okay. So when I go to write my derivative is f prime g plus g prime f, and that's going to give me 15 times 3x plus 4 to the 4th power. That's the first derivative of the first function. We keep the second, which is 2x plus 5 to the 7th, plus, now we want to take the derivative of the second, that's going to be 14 2x plus 5 to the 6th power times the first function, which is 3x plus 4 to the 5th. So example 5 is really a product rule, but we use the chain rule to find the derivative of some of the pieces. Does that make sense? Is there any questions about this one here? All right. Try number 4. Okay, let me go over this. So I guess we all see that this is a product rule. F is going to be t squared. Your g is going to be cosine of t cubed. So when I calculate the derivative L prime of t, the derivative of the first thing is going to be 2t. I keep the second thing, which is cosine of t cubed, plus the derivative of the second thing, I need to use the chain rule. So the second thing, that's going to be, the derivative of cosine is negative sine. I keep the inside, which is t cubed, multiplied by the derivative of the inside, which is 3t squared. So that's the derivative of the orange piece there. And then I need to multiply by the derivative, multiply by the first function, which is t squared. So let me simplify this a little bit. This will be 2t cosine of t cubed minus 3t to the fourth sine of t cubed. That makes sense? Any questions? All right, no questions. Good.
Wait, can you tell me what G prime was again?
Mhm.
I'm confused on that part.
Yeah. So first thing, I want to make sure, I'm going to answer your question, but I want to make sure you are not confusing cosine cubed t with cosine of t cubed, right? Because they mean totally different things. I want to make sure.
Yeah. Yeah.
You know that's true. Okay, good. Perfect. So if I had call my g cosine of t cubed, then when I calculate the g prime, the derivative of the outside function is negative sine. You got to keep the inside, which is t cubed, got to multiply by the derivative of the inside, which is the derivative of t cubed like that. So that's going to be negative sine of t cubed, and that's going to be times 3t squared. Does that make sense?
Yeah.
And then when I
Thank you.
simplified, I just multiplied t squared times t squared. That's how I got the t in the fourth. You add the exponents. You have two things with the same base multiplied together. Make sense?
Yep. Thank you.
Yep, no problem.
Sorry, when simplifying, how'd you get 3t to the fourth?
T squared times t squared is t to the fourth.
Okay,
Times 3 is 3t to the fourth. I just moved it in front. Make sense, sir?
if we didn't simplify, would that be okay?
I'm going to say yes, but you should be able to simplify.
Okay,
Mhm. And sometimes I'll ask for a second derivative, and you don't want to take the second derivative of this thing. It's like a double product rule, you know. You'd rather simplify first, I would say, for the second derivative. Like acceleration, you know.